Hello everyone, welcome to Physics is Fun. Today we will discuss a very important concept which is often misunderstood and misinterpreted from the chapter friction. Suppose you have a block and it is placed on a floor. An external force is applied on it in order to move this block. So I am writing it, this is an external force. Right. So we know that immediately there will be a force of friction that comes into play. Now, whenever these two surfaces, this surface and this surface, the block and the floor, they are rubbing against each other, then the charged particles which are present on these surfaces, they interact with one another. And owing to that interaction, there is a contact force which comes into play. Please understand this very important concept, that when the surface of this block rubs against the surface of this floor, then the charged particles which are present on these surfaces, they interact with each other, and that interaction results in a force which comes into play and which necessarily does not act perpendicular to the contact surface. So what we can say, that by virtue of this interaction, there is a contact force that comes into play. So we can say this is a contact force, and that contact force can be resolved into two components. So we can resolve this contact force into two components. This one vertical component and one horizontal component. This vertical component of contact force, we are calling it normal reaction force, and the horizontal component of contact force, we are calling it the force of friction. Okay, so that is the basic origin of friction. So whenever the two surfaces are rubbing against each other, then by virtue of interaction of the charged particles on those surfaces, a contact force comes into play. This contact force is not essentially necessarily perpendicular to the surface. This contact force can be resolved into a vertical component which we are calling as normal reaction, and a horizontal component which we are calling as the force of friction. Now this contact force is making some angle with normal reaction. We are calling it, say, phi. Now many of you will immediately say that this is the angle of friction, which is not true. Angle of friction, that concept only comes when this force of static friction, if I am calling this one as static friction, has attained a maximum value. That is, when this force of friction is limiting friction. So one very important concept is that static friction is a self-adjusting force. So when you are applying an external force, the static friction adjusts its value, and it may also adjust its direction if need be, okay, according to situation. So static friction is a self-adjusting force. Now you have connected this block by a string, and slowly you are increasing this force, the external force. Alright. And when you slowly go on increasing this external force, then the static friction also goes on increasing accordingly. Okay. So I will just show you one more example. Suppose let me take a case. And for this particular case, I will just tell you that I am lifting the static friction which acts tangentially to these two surfaces of contact from here to the center of mass. Because you see, from the center of mass of the block, what is acting? The weight of the block is acting in the downward direction, mg. Okay. So force of friction will always act parallel to the surface of contact. Okay. That is tangential to the surfaces which are in touch or in contact with each other. But for the sake of understanding or better simplicity, sometimes we may lift this force and put it here, though it is not acting through the center of mass. Okay, for understanding I will do it once. Now what I am telling is that suppose I increase this external force. So if that external force that has been applied here, if that is increased, then what will happen? Then static friction will also increase, right? So if static friction increases, then what happens? So if we increase this external force, then automatically, as static friction is self-adjusting in nature, you see the force of static friction increases as well. You see, this is a longer ray, I should say, or a longer arrow in comparison to this one. So evidently, if this force increases, then what will happen? This contact force over here, it bends more towards the greater force, right? So Fc, which is the contact force resultant of normal reaction and the static friction, it bends more towards the force of friction, and as a consequence, this value of phi 1 I can say is definitely phi 1 is greater than my previous case phi. Now if I decrease this external force, if this external force is decreased, then what will happen? Then definitely my force of friction has to decrease as well. So if force of friction decreases, it becomes small. So I am telling the force of friction is this. This is the force of friction, very, very small. So in that case, what will happen? So again I can make a vector parallelogram, and the contact force, which is the resultant, it makes an angle phi 2 with normal reaction. So very clearly I can conclude, and I can see very clearly that this phi 2 is less than phi 1. So what is the whole idea? The idea is, when you are applying an external force and the body is at rest, static friction comes into play. And if the external force is gradually increased by small amounts, the static friction goes on increasing until and unless it hits a maximum value. And that maximum value of static friction is called limiting friction. So if I say that now the external force has come to that extent that the block just starts sliding. Okay, so I am just looking into the situation when the block just starts sliding. Then the force of friction will attain a maximum value, and we will call it limiting friction. Now as I told you, I will just lift the force of friction from here to the center of mass for a better understanding of the situation. So this is the maximum value of static friction. Okay, so I am writing it as FMS, maximum value of static friction, FMS, or limiting friction. So in that case, what will happen? The resultant contact force will act in this direction. This is the direction in which the resultant contact force will act, and when this happens, then this particular angle attains a maximum value, right? We can call it phi max, and this phi max is the angle of friction. So by definition, angle of friction is the angle between the maximum value of static friction, angle between the resultant of maximum value of static friction normal reaction with that of the direction of normal reaction. The angle between the resultant of normal reaction and limiting friction or maximum value of static friction with that of normal reaction, that is called angle of friction. So this phi max is our angle of friction. Now please see, here this FMS has attained a maximum value because you applied some external force. So this is your external force. Now this external force and this mg they are acting here. So if I take their resultant, the resultant of these two forces, I am going to get this. So I am writing it FR. So basically, what is the core concept? That when the block just starts sliding, lay emphasis on this word just. When the block just starts sliding, then what will happen? Then F external and maximum value of static friction will be equal. So I can say F external is equals to FMS. And definitely normal reaction is equal to mg. So very interesting thing to understand, that if this situation is satisfied, that means N and mg are equal, FMS and F external are equal, then this resultant force and this contact force, they will also be equal to each other. And the angle which will be formed, suppose if I call this angle as alpha, so I can also say that alpha is equals to phi max. Okay. So when the block just starts sliding, then what we can say? We can infer two things. First and the foremost thing, that this resultant force is equal in magnitude but opposite in direction to the contact force. That is one conclusion. Second conclusion is the angle, this alpha is equals to phi max. And what is this phi max? This phi max is nothing but the angle of friction. This phi max is angle of friction. So if I want to know that under what condition will the block start sliding, now please understand this. If the block has to slide, this is the block just starts sliding. So block just starts sliding, what is the implication? Implication is that it starts moving with zero acceleration. So its motion is with uniform velocity. Now if you increase the force, the block will start moving with a greater acceleration. So if you increase this value of F external, now see, already friction has attained maximum value. Friction cannot attain any more value than this. So this limiting friction will convert into kinetic friction because the two surfaces will be sliding on each other. Kinetic friction technically is smaller than limiting friction, but by a very small amount. Okay. So basically, now if you increase this force of friction, this external force, this arrow will become longer and the resultant force will move towards that longer force. So alpha will increase and alpha will become greater than phi max. So what is the condition for the block to slide? Condition for sliding of the block. So condition for sliding of the block is definitely, I can say that alpha should be greater than or equal to phi max. Okay. That is very, very important to understand. Alpha is greater than or equals to phi max. Now if I want to know what is this phi max, so fundamental concept of friction. So tan phi max is perpendicular by base. What is this perpendicular? Maximum value of static friction. So tan phi max is equals to maximum value of static friction by base. What is the base? Normal reaction. What is maximum value of static friction? Mu s into n. What is mu s? Coefficient of static friction by normal reaction. Normal reaction cancels. So basically you get phi max is equals to tan inverse mu s. And what is this mu s? Mu s is the coefficient of static friction. So in order that this particular block slides on the floor, What condition has to be satisfied? Alpha greater than or equals to phi max. And what is phi max? Phi max is the angle of friction. I hope all of you understood these fundamental concepts of friction that many of you have problem in. I have experienced this while teaching my students, that many students don't understand this very basic idea. Whenever they draw this angle, they think this is angle of friction. First of all, that is not true. This phi max is angle of friction. These are just angles that are formed, and that can vary. But you can never get an angle greater than this. But this can be varied. Why this can be varied? Because F external can be varied. But FMS cannot attain a greater value than this. This is limiting friction. I hope this discussion cleared some fundamental concepts of friction, and it will definitely help you in order to solve some numerical problems, the tougher ones, and conceptual numerical problems based on friction. Have a good day, everyone.